Now, when you put a voltage across an inductor, across a circuit with an inductor, you're trying to build current. And normally the current would build very fast. If the inductor wasn't there, the current would build almost instantaneously. But as we've said, the inductor, as you build current, creates a magnetic field that opposes the building of current. So inductive now we've seen that inductive reactance, what we want to call inductive reactance, is omega L. So when omega is high, omega L is going to be high. When omega is low, omega L is going to be low. So why is that? Well, a low omega gives the current plenty of time to build. Okay? The current's going to build exponentially toward whatever current you get from that voltage. So the current has plenty of time to build. The current stays where it ordinarily would be, and we aren't suppressing the current very much if we have a low omega. With a high omega, again, you're switching the voltage. You're going from positive to negative to positive to negative, and you're doing that quickly. Well, the current, you're not giving the current time to build to the high voltage. You're not giving it time to build toward what it would be with a low voltage. The current just doesn't have any time to build, so current is suppressed. So we see that a high omega creates a low capacitive reactance, but a high inductive reactance. Okay? So this is like high resistance. And a low omega gives you a high capacitive reactance and a low inductive reactance. So you can use capacitors then to filter out high frequencies. You can use inductors. You can use capacitors to filter out low frequencies. You can use inductors to filter out high frequencies, and vice versa. You can use inductors will pass low frequencies, and capacitors will pass high frequencies. So this allows you to build filters, and of course the whole process of designing filters, something I've never actually done, is highly complex. You can make some really sophisticated filters. Okay, now we want to get to the phasor diagram. Okay, and I want to explain that briefly. Because the phasor diagram shows you how the capacitive reactance, the inductive reactance, capacitive reactance, inductive reactance, and the resistance work together to determine the way given frequency is going to affect a circuit.